In Chapter 4, we'll be working a lot with fractions. So our lesson 4-1, prime factorization, is a key lesson for us to understand. Our main idea, find the prime factorization of a composite number. That's what we're going to be working towards in this lesson. Some vocabulary we need to be familiar with are prime numbers, composite numbers, prime factorization, and factored trees. A prime number is a number that only has two factors, 1 and itself. Examples of prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. These numbers will continue, but as we talk about each one of them, the only factors that each of these numbers has is 1 and itself. So 2 times 1 is 2. 3 times 1 is 3. There's no other way we can make these numbers using multiplication of factors. 5. 5 times 1 is 5. We can't do 2 times something to make 5. It's just 5 times 1 is 5. Composite numbers. For example, the number 14 is composed of 1, 14, and 2, and 7. 1 times 14, but also 2 times 7 make 14. So therefore, we can make 14 using factors other than just 1 and itself. Prime factorization is a technique we will use to break a number down, break a composite number down into its factors, and to do this we will use a factor tree. For example number 1, we just need to determine whether the number 63 is prime or composite. So we don't need to do anything with it, but we want to identify whether it is prime or composite. So let's take the number 63. The question is, can something other than 1 or 63 divide into this number? Since I have a 6 and a 3, I know that when I add those two digits together, I get 9. 6 plus 3 is 9. That is a rule, a divisibility rule of 9. So I know that if I divide this number by 9, I will get another factor, which is 7. Therefore, this is a composite number because I can prove that there are other numbers besides 1 and itself, 1 and 63, that can make this number. Example number 2. Determine whether the number 29 is prime or composite. Okay, so let's take the number 29. I know that 1 can be used to make 29 and also 29, but the question is, can any other numbers be used? Since this is an odd number, I know that 2's will not work. My rule for 3's is that I should add the two digits together, and I should be able to divide that number by 3. So 2 plus 9 is 11. I cannot divide 11 by 3. When I think about my 4's, I know that 4 times 7 is 28, but no number can get me 29. 5's, this number does not end in a 0 or a 5. 6's, 6 times 4 is 24, and 6 times 5 is 30, but there's no number that can get me to 29. 7's, 7 times 4, again, like I gave before with the example, 7 times 4 is 28, so this will not work. 8's, 8 times 3 is 24, 8 times 4 is 32, that does not work. 9's, again, just like 3's, it has a rule. If I add them up, I should be able to divide by 9. 2 plus 9 is 11. I cannot divide that by 9. So 29 is a prime number because I cannot factor it with any other numbers other than 1 and itself. Example number 3. Find the prime factorization of 100. To do this, I'm going to use a factor tree. I'm going to start 100 up here, and I'm going to stem off with 2 branches. Since 100 ends with a 0, I'm going to start with the prime factor of 5. How many times can 5 go into 100? 20 times. So I'm going to make a new branch off of 20, and 5 is a prime number, so I'm going to circle it. Since 20 ends in a 0, I'm again going to use the prime factor of 5 to break this number down. And 5 goes into 20 4 times. Since 5 is a prime number, I'm going to circle it again. And 4 is an even number, so I'm going to make another branch. Since 4 is an even number, I'm going to use the prime factor 2, and 2 goes into 4 2 times. So, since these are both prime factors, I'm going to circle both of them, and I'm going to write my prime factorization statement. I have 2 5s and 2 2s. So when I rewrite that as a multiplication statement, I can rewrite 100 as 5 squared times 2 squared, and that equals 100. So 100 is a composite number, and it is composed of the prime factors 5 and 2, and we have 2 5s and 2 2s being multiplied. Example number 4. Find the prime factorization of 64. We will again use a factor tree, so I'm going to start with the number 64 up on top, and I'm going to branch down. Since 64 is an even number, I'm going to start with a prime factor of 2, and 2 can go into 64 32 times. 32 again is an even number, so I'm going to start with a prime factor of 2. 2 goes into 32 16 times. 16 is an even number, so I can use the prime factor of 2. 2 goes into 16 8 times. Since 8 is an even number, I can use the prime factor of 2. 2 goes into 8 4 times. And since 4 is an even number, I can use the prime factor of 2. And 2 goes into 4 2 times. Each time I ended with a 2, those were prime factors, so I didn't extend my branch. So how many 2's did I have? 1, 2, 3, 4, 5, 6. So I can rewrite 64 as a prime factorization of 2 to the 6th power, and that equals 64. So 64 is a composite number. It's composed of 2 to the 6th power, because 2 is my base, and I'm using 2 6 times. In example number 5, we're going to factor 21 times m squared times n. Notice the difference between the word factor and prime factorization. When it asks us to find the prime factorization, we're going to combine all of our factors and write them using exponents, 2 to the 6th. When it says to factor a problem, I want to break it apart into all of its individual factors. So 21 times m squared times n. Well, first I'm going to work with my number 21. Since I know that 3 is a prime factor that goes into 21, 3 goes into 21 7 times. And both of these are prime factors, So I can stop right there. I need to break apart m because I see that there is more than 1. So m squared is made of m times m. And n, there's only 1. Since there's no number up here for an exponent, I assume it's 1. So it's simply n. So 21 m squared n can be factored by writing 3 times 7 times m times m times n. Again, please notice the difference between factoring a number and finding the prime factorization. When we're finding prime factorization, we want to use the factors and describe them using exponents. Whereas factoring the number, we want to simply list all of the factors being used.